So good morning everyone. I'll be talking today about the amount of storm sewage and how estimation is made. So these are wastewater that must be disposed of from our community. First one is the domestic, or also called sanitary wastewater discharge. Includes residences, commercial establishments, and institutional establishments. For example, is our university and the Sangguniang Panglungsod ng Davao. Next in line is the industrial wastewater. Includes factories, warehouses. It includes also infiltration or inflow extraneous water that enters the sewer system through various means and storm water. So this system is been discussed by our previous reporter. So also storm water resulting from precipitation runoff. So what is storm sewage? Storm sewage or storm water is a runoff from precipitation that is collected in a system of pipes or open channels. Also, refuse liquids and waste carried by sewer during or following a period of heavy rainfall. So the peak rate of runoff depends upon various factors in estimation of storm sewage. So what are those factors? Factors including type of precipitation, intensity and duration of rainfall distribution, soil moisture deficiency, climatic conditions, shape, size, and type of catchment area, etc. So there are three methods that are used in estimating storm sewage: the rational method, empirical formula, and digital computer simulations. But we will only discussing about rational method. When we say rational method, it is the simplest method to determine peak discharge from drainage basin runoff. Also, the most common method used for sizing sewer systems. So this is the equation for rational method, wherein Q is equal to C times I times A, wherein Q is design discharge, C is the runoff coefficient, and I is design rainfall intensity, and A as watershed draining area. So in runoff coefficient, so this is a coefficient that represents the fraction of rainfall that becomes runoff, and also depends on type of surface. So this is the table. This table is available in my written report. So I will not discuss much about this. So sample problem. The catchment area of a city is 200 hectares, assuming that the surface on which the rain falls is classified as follows. So type of surface, percentage area, runoff coefficient. So roof, 20% area of 200, runoff coefficient of 0.9, pavement and yards, 15%, 0.8, lawns, gardens, 30%, 0.15 runoff coefficient, macadamias roads, 20% area, 0.40 coefficient, and vacant plots, 15% and 0.10 coefficient. So calculate the impervious factor. If the maximum intensity of rainfall is 40 mm per hour, Calculate the quantity of storm water which will reach sewer lines. So solution. Impervious factor or overall runoff coefficient. So in solving this, you needed the area and the coefficient, runoff coefficient. So with the area of 200 times 0.2, 0.2 is from the percentage area. So percentage area, you just multiply it with the coefficient. So 200 times 0.2 times 0.9 plus 0.15 times 0.8 plus 0.3 times 0.15 plus 0.2 plus 0.4 plus 0.15 times 0.10 over 200 area and the percentage area of the types of area. Types of surfaces. So with percentage surface of 0.2 plus 0.15 plus 0.30 plus 0.2 plus 0.15. So in overall, the answer is 0.44. So that is our coefficient. So Q equals CIA over 360. So 0.44 times 40 times 200 over 360. So the answer is 9.778 m cube per second. So thank you for listening and God bless us all.